to the new video. So today we're going to learn about reinforcement learning and its components. So let's get started. First of all, what is reinforcement learning? Reinforcement learning is a machine learning algorithm where an agent learns to make decisions by interacting with an environment. It aims to maximize cumulative rewards over time by learning from consequences of its action. The agent receives feedback in form of rewards or penalties based on its action and adjusts its behavior accordingly. Over time, through trial and error, the agent learns an optimal policy for decision making. So, overall, reinforcement learning is a type of algorithm, machine learning algorithm, where an agent needs to take action first, then, according to the action, the it will receive either a reward or an punishment or penalty. If it receives a either of those, according to the reward or penalty, it will choose another policy or another method to make the thing or make the decision again. So RL differ from other learning paradigms or other learning, different types of learning, that is supervised learning or unsupervised learning. It is more focused on learning from interaction rather than from pre-labeled data. So as we know, supervised learning is mostly labeled data and unsupervised learning mostly unlabeled data. But here it is not necessarily needed data or not necessarily focused on data. It's often used in scenarios where explicit supervision is not possible, such as in robotics, gaming, autonomous vehicles. So because there is not data is not needed, or there is decisions, or there is things that needed are decisions which will make agent learn. So agent's goal is to find a strategy that maximize long-term rewards rather than immediate gratification. So mostly the agent's main goal should be it's find a strategy which will give it a long-term reward rather than some short time of reward. A common example is training a robot to navigate through a maze. The robot receives positive feedback for reaching the goal and negative feedback for making incorrect moves. Through repeated interaction, it refines its behavior to reach the goal efficiently. So, main components of RL. So, in RL, there are many components which are really needed, or which are mostly the basics or the things that make this algorithm a really exciting and a very new algorithm. So there are mostly four key components, which are the agent, the environment, action, and rewards. Other than that, there is policy and other things, but mostly these four algorithm or four components are the most main components which are very needed for RL. First, the agent is a learner or decision maker that interacts with the environment. Uh, agent is a very known thing to us, because agent which we are learning about new things in as agent as agentic AI or anything. You make an agent like you make a model, that is an agent which make which is here is a learner or decision maker which will make the decision that and interacts with the environment. The environment is everything the agent interacts with, including external system or the problem space, such as a game's world or robot's physical surrounding. So environment is just like our environment in which we live. So for agent, it has been given an particular environment in which the agent has to make decision according to the environment. So, just for example, here is given the game's world or robot's physical surrounding, such as that. And the actions. Actions are the choices or moves that the agent can make to influence the environment. So, how can a robot can make it so just like differently, such as moving a robot or choosing a game move. As we are playing a game in in the environment, we make a move, or a robot in the environment either take either make a move to go forward, go backward, or go sideways, or move, or anything else. That is the actions of the agent. Finally, rewards are the feedback signals that the agent receives after performing an action. So after performing an action in game, we either make a if we make a good action, then we receive a penal or a good action, we make a good reward, and if we make a bad action, we get a penalty. So rewards can be positive, indicating successful action, or negative, indicating failures, guiding the agent towards the learning the optimal behavior. Together, these components form a feedback loop where the agent makes decisions or actions, the environment responds with new states, and the agent receives rewards or penalties to adjust future actions, gradually learning to better decisions. It's like a loop where the agent makes first decisions, and according to the decision or the action, it receives a feedback, or either it should be penalty or it should be a reward. So the agent receives a reward or penalty, it adjusts its actions again to make another decision, which will make a better decision or which will make another bad decision. But the goal is to make the agent better decision to make the gradually learning better. So first we are going to learn about agent. So an agent in RL is the entity responsible for taking actions within the environment to achieve a specific goal. So just as we discussed previously, agent is a entity or a responsible a model which take actions inside the environment to achieve a specific goal. So let's say we have we have a dog in an environment. So let's take environment as a house. Inside the house we have a dog, and our dog is our agent, and the house is our environment. The agent's goal is to maximize cumulative rewards by learning the best course of actions through trial and error. It makes decisions based on its current state and selects actions that are expected to lead to the highest long-term rewards. So let's take an example for it. So let's take we have a dog which is our agent, and the room is our environment. Within the environment, we have a goal to make the dog sit. If the dog sit, we will give it a treat. So first we will say the dog to sit. If it doesn't understand, then we will not give anything. We gradually we will show them, or gradually we will keep making the decision for the, or we keep telling the dog to sit. At last, if the dog sits, we will give him a reward. And again, if we keep repeating this thing, we keep repeating this action, the next time or any time, when we say the dog to sit anywhere, the dog will sit, because it has been understood based on the rewards it has been getting. If the person says it's to sit and I sit, it gets a reward. The agent interacts with the environment by observing its state, choosing action, and receiving feedback in the form of reward and penalties. As the agent interacts with the environment, it uses this feedback to update its strategy, aiming to improve its performance over time. In some cases, the agent's behavior might evolve from random action to more sophisticated strategies as it gains experience. So, for example, uh, so RL include robot learning to navigate, software program playing games, or autonomous vehicles making driving decisions. The agent's behavior is guided by algorithms that balance exploration, trying new actions, with exploitation, choosing best known action. So the best agent's behavior guided by algorithms that are balance exploration. So exploration means taking new types of action, which can gives a another which can give either penalty or reward, or exploitation, using the best known action. As it has learned, the dog has learned that if I sit, I will get a reward. That is called exploitation. Dog has exploited that if I sit, I will get a reward. If the dog instead of sit, it gets laid or it's run, it take a it take a new action for that. So next we are going to learn about state. A state in RL refers to a specific configuration or condition of the environment at a given time. It represents the information available to the agent at that moment which the agent uses to decide on the next action. States are critical because the agent's decision depend on the current state, and different states may lead to different rewards. So this just like we discussed about the dog example. Let's say dog did not first dog has no information about what is sit, what is sleep, what is run, what to do, anything else. So first when we saw the dog to sit, it's run. So it take action based on its current state, which does not give him any reward. But eventually, as the dog evolved, as the dog understood, as the dog's mind evolves, we keep giving him instruction to sit, 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 sit. Next, when he began to next time when we say sit, at this point when he sits, it states leads to the state's action leads to the our our achievement or our goal. So we give him a reward. States can be simple or complex depending on the problem. For example, in a board game, the state might be arrangement of pieces on the board. So states cannot be is a very complex thing because in a chess game, you can understand that there are so many pieces and there are so many choices you have to make. So state for any single pieces, you can understood that there are many pieces and you can make any kind of action from there. So that's why states can be complex. Yeah, robot navigation problem. The state might include robot's position, speed, or sensor reading. The state is typically represented as a vector of variables or features that describe the environment at a particular time. So simply, if we have to, define state, what is state? So state is typically represented as a vector because it has some value and it has a direction. It's easy that where here you can see that in robot navigation problem, the statement includes robot's position, where is robot standing, what is robot speed, how much speed robot can move, or sensor reading, and what can robot sensor. Is there any obstacle in his way, or something there is a wall in front of him? That is the sensor reading. So that is if we add everything into the robot's mind or robots, it is become a state of robot. A RL agent uses the current state to assess its situation and select actions that will improve its chances of achieving its goal. So RL agent uses the current state to assess its situation. Simple thing, it is RL chooses the current state to chooses its assess its situation and select action. So the agent or the model chooses first assesses its situation or state in which it is in and select action that will improve its chances of achieving its goal. The state is continuously updated as the agent takes action and the environment evolves, creating a dynamic learning process. Understanding and accurately representing states is essential for agents to learn effective strategies. So, state is very interesting or very important because it is where the agent learns to make actions or takes action, which will give its reward or penalty according to the action. Next, action. Action is in RL refers to choices or moves made by the agent to influence his environment. Simply, we have understood that the dog, if it should say the dog sit and it sits, it takes action which will give him a reward. These actions how the agent interacts with the environment. So that's how if we say the dog sit, it sit and it it interacts with the environment as I am sitting or I sit, aiming to transition from one state to another in a way that maximize future rewards. The action space can be discrete, left, right, off, down in a grid. So we'll in future I will show or the next video I will show a grid example. We will understand everything here there. What is left, right, up, down in a grid or continuous, adjusting the speed of car. So simple if we are trying to understand the speed of the car. So in a plain road, the speed of car can be 60, 40 to 60, but in a if there is the car there is a very heavy traffic, the speed of the car must be adjusted to the according to the traffic's how much traffic there is or how many cars there are. In RL, actions can have immediate or delayed effects. For instance, The agent might take an action that doesn't result in immediate reward but leads to better outcome in the future, such as moving closer to a goal. Actions are typically selected by agent's policy, a strategy that dictates which action to take based on the current state. So it's not, I mean, let's take a new example or a next example. So if we throw a ball and say the dog catch the ball and catch the ball and come back to me, so dog have to dog has to go few steps or run few distance to take the ball and come back to me. So dog takes some actions. After that, it gets a reward. It doesn't take one action and it gets a reward. So that is what written here. The agent's ability to choose the right action is crucial for success of the learning process. The set of actions available to the agent may vary depending on the environment and the current state. A key challenge in RL is balancing the exploration of the new action with the exploitation of known successful action. So basically, there is a thing in future we will study that sometimes agents become so sharp that it started to exploit. I mean, it started to take only those action which will give the agent only reward, but doesn't make any difference in the in the value or in the choices we have getting or in the value or anything we are getting. So that is exploitation and exploration. Exploration means even if the it's getting reward, sometimes the reward becomes overfit or over which we do not want and which we want the it should make some exploitation to get some another reward. Even if it's a penalty, it should explore in something or explore more. Then we get comes to reward. The reward function in RL is a mathematical function that defines the feedback an agent receives after taking an action in a particular state. It maps the state pair to a numerical value, which can be positive if it gets reward, negative if it gets penalty, or zero. Zero is something we will study, indicating how favorable or unfavorable the action was in the state. The reward function is essential because it guides the agent's learning process, helping the agent understand which action lead to desirable outcomes. In RL, the goal is the agent to maximize its cumulative reward over time by selecting actions that yield high rewards. The reward function influences the agent's behavior by assigning values to states and actions. For instance, in a game, agent might receive a positive reward for scoring points and a negative reward for losing a life. The design of the reward function is critical because it shapes the agent's learning. If the reward function is too sparse or poorly defined, the agent may struggle to learn an effective policy. It must carefully crafted to reflect the desired objectives of the task or environment. So the reward is simple if we have to understand the reward, what is reward is in RL. So basically, reward is what agent gets by making action in the current state to different state. So in a particular action, in a particular state, if agent takes a action and it gets a reward positive, then it makes a good action. If it gets a negative, then it is a very bad action. Simple as that. And we have to make the reward function or we have to define the reward function so good that agent can learn from its effective policy or a policy it will get or it's get a simple thing, a simple view which will very good for it. If it is really poorly defined, so agent will, even if I run the agent for a long time or give it more, keep making decisions on, keep making actions, will not get a very good reward in the future. So next is policy. Policy in RL is a strategy or a mapping that determines the agent's action based on its context. Defines the agent's behavior by specifying which actions to take in a given state. Policies can be deterministic, always choosing the same action over for a given state, or stochastic, choosing action based on a probability distribution. So policy is just very, if I have to understand in a simple way. So policy is a, let's say in a the dog we have throw the ball and we want the dog to run and take the ball. I mean, let's say there are four ways, and among the four way, only one way. The four way will get the ball, dog will get the ball and come back to us, but only one way. That will be very shortest way for the dog to get the ball and come to us. So that should be our policy. The dog should take that path and take the ball and come to us. That should be our policy. That is the policy we are making. The whole dog will take action in the four paths differently, and eventually, at least we should want, or we want that even if whenever I throw a ball, dog should take the shortest path to get the ball and come to me. So policy can be two types. Policy is a deterministic. So we should make only one path. Dog should take only this path, and which will be shortest path, which will go and come to the ball. That is the deterministic way. We have determined the way for the dog, or stochastic path, which I have discussed. I mean, is just I have discussed that there is four ways. There is probability. Dog have probability of going any path, any of the path from the four path we have. A policy guides the agents throughout the learning process and dictates how it interacts with the environment. So the goal is for the agent to learn an optimal policy. So just as I said, dogs should learn the way to get, even if there are four paths, dogs should learn to take the shortest path to get the ball. Optimal policy, one that maximizes cumulative rewards over time. For instance, a policy might dictate that a robot should always move forward unless an obstacle is detected, at which point it should turn. In practice, the policy can be represented as a function or table. In the case of small environments that map states to action in larger, more complex environment, the policy might be learned through a deep learning methods where a neural network is used to approximate the optimal action. So, in the last line is the most important line we should understand. In practice, the policy can be represented as a function or a table. So, policy can be mapped in a table for small environment, because for big environment or the environment in which where we are taking so many states or so many actions, it's impossible to make it in a table that maps states and states to action. So in particular state, our agent taking which type of action. In larger or more complex environment, the policy might be learned through deep learning methods. So in big environments, the policy can be learned through deep learning methods such as neural network, which will approximate the optimal action. So from that we can approximate, or we can take average of the optimal actions. So this is what reinforcement learning and its components are. Thank you, and we shall meet in the next video.